through the collective efforts by the industry, especially the Chinese operators, China Telecom, China Mobile, China Unicom, CAI, CT, and CCSA. There are a lot of good works even in China to define the next generation optical networks. And here, with the contribution from the industry, there is a vision of the F5G, the fifth generation of fixed network, to not only support 5G, but also complement the 5G to provide our own direct use cases. And within ETSI, the European Telecommunications Standardization Institute, F5G has been established as one industry-specific group. So within the group, there are more than 80 participating companies to work together on a weekly basis to define the new use cases and the new technologies to support F5G. And so basically the idea is to bring fiber to the not only not smart, but also not meter, not only to homes, but to rooms, not only to offices, but to desktops, to desks, to machines in the factory. And then in early this year, in February, there was a first release of F5G use cases. There were 14 use cases reported for things such as cloud virtual reality, for public services, passive optical LAN network to have energy efficient connections for campus networks, high quality private LAN for banks, hospitals, and other mission critical institutes. And then PON for industrial internet, scenario-based network to really meet the quality of service requirements of individual services, and so on. So currently, the ETSI F5G group is working on the second release to be publicized very soon. There are already 18 new use cases have been accepted, including data center interconnections, media transport, rural broadband to minimize the digital divide, and private LAN connectivity to multiple clouds, which is very useful in the cloud era, and also edge and the cloud-based quality assessment in production sites, and so on and so forth. So to enable those new use cases, our fixed network need to also advance and also enhance. So you can find actually there were two very exciting industry forums yesterday at our ACP this year, talking about all optical service networks for F5G and next generation optical switching and translation technologies for F5G and beyond. So the key point is service here, meaning our optical networks have been evolving to deliver real value and to have direct support for end users, to be service-driven, service-centric, rather than just a hidden type. So in that sense, you can treat our optical connection to be like a wireless connection, like 5G, to really deliver values to the services. For that, we need to have the service plan to be well determined, to have optical service protocol to do the control and the management of the service plan, and also the underlying physical plan. Then we can leverage advances in big data analytics, digital twin, AI-based basically analytics to make the network intelligent and universal. So then end-to-end network slicing is a key technology there. The paper submitted by the group from F5G, led by the chair of F5G, Dr. Luca Pensando. So basically, the idea is to address all the end use cases we mentioned earlier by giving a dedicated network slice And the slice types will be falling into the categories of I5G, the enhanced fiber or fixed broadband for high bandwidth, guaranteed low latency service, massive connections for connections such as Internet of Things. And sometimes for industry applications, we need both high bandwidth and low latency. So we have a dedicated slice for it. Now, with all the end-to-end network slicing being implemented and realized in the near future, we can really address end users, and then we can penetrate even closer to end users in a home, to homes, to address all the different requirements to have a better connectivity, better coverage, and seamless low weight Wi-Fi roaming and intelligent operation. So, like smartphones are very important when you are moving around outside the home. So 5G for that is really important. And then for fixed network, if we are inside the home, inside the building, I5G has really delivered the value. And for that, in China, CCSI and others had made a lot of contributions in this domain. And in ITU, there was a recent technical paper to really summarize the use cases and requirements for the so-called fiber to the room technology. And you can freely download the white paper from the website. So basically, inside building or homes, we can provide, business uses, education uses, and medical usages for communication, for entertainment, for energy consumption and security, and also make everything intelligent. And more recently, in June, knowing the importance of such initiatives, ITU, ETSI, CCSI, and Broadband Forum, they team up to have a workshop to talk about fiber to the room. Yeah. And even in this year's conference, there were several reports, papers about fiber to the room. And there was one paper jointly reported by Huawei and Orange Maps about real-time implementation of fiber to the room with guaranteed quality of service and fast roam, and also high speed home networking. So now let's move on to the further expansion of the application of optical and the photonic technologies. So not only we're using optical and photonic technologies for communication. Nowadays, as you know, we are using our technologies to support autonomous driving. For example, using LiDAR. Here shows a road test of a recent demonstration with a 360-degree coverage from multiple LiDARs and multiple radars collaborating in a unified version. Then with LiDAR, you can have up to 200 meters of detection of incoming vehicles, and also to have a wide-angle detection of surroundings to increase the safety of a future autonomous driving. Then we can use the display technology to have this augmented reality head-up display to really allow you to have a brand new experience when driving, and also to enhance the safety of driving. With this picture generating unit, we can have an intelligent way to design the optics so that you can use the windshield itself as a big widescreen display to show the traffic condition with augmented reality to help you to have a very safe journey and easy journey, and also relaxing journey when you need it for passengers, not for drivers. Yep. Then optical computing. We heard a lot about optical computing. There was a very good paper published 4 years ago by this MIT group in Nature Photonics, well cited, to talk about the potential of using optics to do computing. On the other hand, people also realize there are challenges here. For example, in electrical computing, it's very easy to generate nonlinear process, but in the optical domain, it's hard to generate the nonlinearity. And there are some challenges to really leverage this. But initially, people may use this kind of ideas for linear operation to accelerate the linear operations for artificial neural networks, as reported in this recent article. Then, before we really have this optical chip to do computing, actually, our optical communication and the photonic community have been helping the high performance community, high performance computing community already. In this year's OFC, there was a very nice workshop on low latency communications. Where do we need it? How do we achieve it? There was a excellent invite talk by Dr. Xiang Zhou of Google, talking about scaling the data center as a warehouse scale computer for supercomputing. Even Tesla, when they reported their AI for autonomous driving, they were talking about the data center scale computing with racks of high performance servers or interconnected. Yeah. So there is a latency need to be on the order of microseconds, really highly challenging. So according to Dr. Xiang Zhou, innovations are still needed in low latency for error correction, DSP amplification, transmission media, and so on. And in terms of transmission media, we go back to fiber. And there was another very good talk by OFS experts showing the commercialization of a hollow core fiber for low latency communication, because the light is primarily guided in this hollow core with latency or propagation latency like air. So you save the latency that way. Then by the group from Europe, University of Southampton, there is another very good design of hollow core fiber called the nested anti-resident nodeless fiber to basically achieve broadband transmission with very low loss, approaching typical standard single fiber loss. So then maybe due to time limitation, I need to be very quick. We also need to work on sensing, for example, to monitor, let me go back, communication infrastructure and worst case and tsunamis, as reported by several good papers in OFC and also in TrueSense articles by Google and others. So basically, you can turn the worldwide submarine network into a sensing network for earthquake monitoring and tsunami monitoring. So basically, the already deployed optical communication network can be utilized to help our host society in terms of monitoring and sensing. And with AI assistance, you can perform vibration sensing, temperature sensing, pressure sensing, and to help a lot of industries and organizations. So going forward, very quickly, we heard from the 5G community, they are already talking about 5.5G in the coming years. Mr. Wang Tao of Huawei gave a very nice talk about